start off. We're with the Beacons program out of UT Dallas, and I'm going to start off with this first slide here. The US is a leader in cutting-edge battery innovation, but transitioning from lab scale innovation to manufacturing really is hindered by a reliance on offshore prototyping. This risks intellectual property and control. So how can we change that? How can we bolster strong domestic prototyping and really accelerate development with safeguarded IP? So typically a university, would be able to support coin cell development or single layer pouch cells, but often want to share an IP. There also is limited prototyping labs in the US available that can actually transition from lab innovation to an automated level of prototyping. With over 80% of batteries made outside of the US, US lithium battery manufacturing is still developing, and much of the supporting industry really is not fully developed. Many of the materials and critical minerals for batteries are produced and processed outside of the US. Over 90% of the critical minerals are mined or processed in China, and this creates an increased supply chain risk. There's also a lack of transparency when sourcing these critical minerals. So these issues, combined with the challenge of workforce shortages for skilled local labor in the industry, creates a challenging situation. So just to introduce a little bit about the Beacons and its purpose, it addresses many of these issues that I just mentioned, including accelerating the adoption of new battery chemistries and onshoring battery manufacturing capabilities, workforce readiness. We are working to develop what we call an ecosystem. It's more of a comprehensive community approach to provide innovation infrastructure and workforce, just to help create a resilient domestic supply chain. So I would say that collaboration really is our catalyst, because Beacons works closely with startups, national labs, various universities, industry leaders, and the Department of Defense to accelerate energy storage breakthroughs. So a significant part of the funding for our program is funded through, the Department of Defense. The Department of Defense's Office of Industrial Base Policy and its Manufacturing Capability Expansion and Investment Prioritization Office utilizes a unique funding model, OTA, and helps position us to continue a rapid growth process. So here are some of the ways on this next slide here that we address some of the concerns that I mentioned earlier. So supply chain transparency for critical minerals. We are working with our partner AUI, and they've developed a tool that is able to map the location of mining and processing facilities globally for critical minerals, giving greater transparency. And this helps us to tell where our risks are and where our gaps are in the supply chain. The other part is workforce development, developed a reproducible and scalable model by partnering with local community colleges to quickly implement training programs in advanced manufacturing that support the battery industry. This is complete with assessments and evaluations built into the program to allow us to have quantitative data for increased expansion. And then an important part of our program is the development of UAV standards. In collaboration with the Department of Defense and industry partners throughout the world, we're creating a industry standard for UAVs. The objective of this is to create basic specs to include dimensions, max swelling, and minimum performance to reference test standards. And move on to next slide here. So the main focus of our presentation today actually is addressing that innovation to manufacturing process. So a domestic prototyping line can really help advance this movement from innovation to manufacturing, and it can help accelerate development. The UT Dallas facility actually is an IP secure facility, prototyping everything from lithium ion, sodium ion, other next gen chemistries. It's available to outside users, outside companies, startups, small businesses, large corporations, and even other researchers. Tim Braun, who's joining me on this presentation, will provide additional information about the facility and more of its capabilities. But an important part to continue on with advancement towards full manufacturing is to have support for scaling from prototypes to full manufacturing. This actually can include things such as connecting startups to established companies, industry matchmaking, and even connecting to possible investors. Now, another part that we have on here is end applications. Our facility, while servicing a wide variety of players in the industry, we've kind of turned our focus a little bit away from EV, and more towards UAVs, grid storage, and various consumer applications. And part of that is due to the long development cycle for EVs. There's a much shorter development cycle for UAVs, grid, and various consumer applications. What I'm going to do is turn my time over to Tim Braun. He's the director of the Beacons Battery Prototyping Facility, and he's actually going to continue to share a little bit more about the facility and how to make that connection between R&D to manufacturing.
Okay, thank you, David. Tim Braun, I'm the director for the Beacons facility at UT Dallas. I come out of industry, 30 years of experience in high-tech industry. Part of that it's in batteries. But to give you a little example of how the university is focusing this facility towards industry instead of hiring a PhD professor to run this, they chose to take a little different approach, and it comes from our history. But I'm going to start this slide a little bit backwards. I'm going to start at the bottom with a little Texas inside joke. Welcome to our Whataburger building. I don't know how many people know Whataburger, but it's the regional burger place that defines Texas, I guess, and that orange and silver is their colors. This whole approach was taken to look at the future and try to see what we could provide or augment into the industry to try to move R&D a little closer to full manufacturing. And the industry has quite a few solid and well-developed TRL level 2 to 4 R&D facilities throughout the United States, but it is lacking the next step, which is a prototype scale production that tried to prove manufacturability in industry standard products like an 18650 or the larger pouch cells in the 10 amp hour to 30 amp hour range. And this facility was designed around that. And then having it located next to a university which has capabilities in characterization and development is also a benefit of it. And we are not only focused just on new battery chemistries, there's also materials that go into batteries, and local suppliers or domestic suppliers and innovators in the battery materials are looking for a place to test out their products and even standard chemistries, along with equipment manufacturers may want a place to test out a new concept in or process development in our facility is designed to accommodate that. You want to switch to the next slide, David? As I talked about, UT Dallas has R&D experience in new gen technologies, and that is one of the benefits. If somebody shows up at our facilities and they need a little more development and need some more help developing it, we can refer them to sponsored research through the university, which help them progress to a higher level. But once they get to a level that they can want to go into an industry package, we try to take them on and move their product forward. Again, trying to, best way to say it is to keep their IP whole and move it forward. And then we also don't want to reinvent the wheel. We're trying to build a relationship with other facilities that provide knowledge and products. And sorry, I'm kind of lost on my thing here, and I need to get back online a little bit. We work with these companies to move people along and then move them into our area. And again, this is to protect the IP. Sponsored research, universities want to share in the knowledge and publish, but a lot of producers don't want to share that knowledge and want to keep it safe. And that's where we can work with these other TRL level 2 to 4s to help you move forward. And I'll step into the facility a little bit more if, David, you want to switch to the next one. The facility opened in the summer 2025, which was just a few months ago. We currently are housed in half of this facility, which has 3,500 square feet of dry room, which we have kept 1,000 of it for expansion to allow us to test out, as I said earlier, new equipment and processes and possibly rent the space to people. But the other 2,500 square feet of it houses a line for both pouch and cylinder cell production at automated levels for consistency's sake. We also have the office space to allow our customers to have privacy and the meetings and be able to participate in the production of their products. Next slide, please. As we know, the process starts with coating. We designate anode and cathode coaters, but it's more based around the chemistry. We keep the water-based coatings outside in a clean room, which is not part of the 2,500. It's in excess of the dry room production space. And then we have a solvent-based coater in the dry room, both with 5-liter mixers to allow for decent runs of 100 to 200 meters of product. And moving forward, next slide, please. Sorry, I'll step back to the coaters. We do reverse comma coating with potential expansion into slot die coating. Okay, sorry, David. Our pouch cells have a maximum size of 80 by 100 up to 12 millimeters thick, which in some chemistries can reach 30 amp hours, but typical is into the 10 to 20 amp hour range, and that's dependent on the number of layers. And with our current staffing, we currently staff 4 people, and we could, in batch format, can produce about 150 cells in a week. But if we were to fully staff up to the design of the room of 12 people and run 2 shifts, we can do fairly large volumes. But the intent is to build a statistically significant sample size to allow people to test at a pack level or prove the repeatability of their chemistry or design. If next one. We also have cylinder cell prototyping at the 18650 format, which typically in an NCM chemistry will produce a 25 milliamp hour cell. This is also designed at a decent sized level. Our winder in the top picture is designed to maintain consistent winding tensions and at an automated level to, again, to build a repeatable cell, which people struggle with in TRL levels with hand winders. They don't get consistent tensioning, and their cell performance repeatability is less than what would be on a fully automated system. It has been designed with feature capability of 21700s, but we haven't implemented that at this point yet. We have testing capability in temperature controlled environments, cylinder cells, 128 channels, and then we have 64 channels of pouch cells and additional testing service through partner labs and through our partnership with other facilities. And picture of the empty space that has electrical and all the facilities ready for additional adding, whether we add in more lines or more processes. It's designed around the scalability. And we are looking at, we are in the middle of initiating expansions into what we call voice of the customer requests. Some of the TRL and TR2 through 4 capabilities are lacking, and there's ask for that. So we're looking into additional capabilities there. Everybody needs more testing and formation capability. So we're looking at the best way to scale that up. And then we're partnering through other facilities for material scale up, and also looking at possibly bringing material scale up for cathode materials into the facility. And we have an announcement on our partnership coming in the fall. But the main thing I wanted to get across is we designed this facility around expandability. The building itself was designed by my predecessor for expandability, and it was easy to put the facility in here. We are sitting next to 5 acres of green space, which would allow for other types, possibly pilot line type expandability. And this ecosystem that David talked about is how we think we can help accelerate battery innovation, is working and communicating as a team and moving the whole industry forward. And with that, I think we should open it up questions, and hopefully I can do a better job of answering questions.